Hey guys, the objective of this video is to look at an example where we increase the vertical effective stress and then decrease it again in a normally consolidated soil. So if I take us back to the diagram we developed in the very first video, so far we've seen along this line, we've seen along this line, we've seen a combination of this line and this line. So the final example we're going to do now is when we start up here and we come to a point of pre-consolidation stress and then we decrease to come up here. Okay, so we're coming up, back up here. So down there and then back up. So that's the final example you guys could get. So the example we've got is a normally consolidated sample is initially at 50 kPa with a voids ratio of 0.9. We increase it to 200 kPa and then decrease it back to 50 kPa. We want to find the final voids ratio given these compressive and reflexive index. So let's draw what's going on as we always do. So we are initially at 50 kPa, so let's make this 50. So 50 kPa, so 50 down here, and our voids ratio is 0.9. Alright, we increase it to 200, so we're coming down here. It said that it's a normally consolidated soil, so we don't need to worry about finding the pre-consolidated stress because it's told us that it's normally consolidated. So that's going to take us to 200. We don't know the voids ratio there, so let's call that E1. And then it said we're going to go back to 50. Okay, now once again, we know that we can only go down the normally consolidated line, we can never go up it, so it means that we're going to be going up the over-consolidated line. So we're going to be drawing a line with a different gradient, so we're going up here like that. So this is our path, that would be the pre-consolidated stress down there at 200 kPa. Okay, so this line, so this segment of the graph is once again taken from here back up. Okay, so this is CC and this is CR. Okay, and our aim is to find E2. So we're first going to find E1. So E1 will equal, from the formulas we've developed previously, will be minus CC. So minus CC is 0.4, so minus 0.4 log of the final effective stress, which is 200, on the initial, which is 50, plus the initial voids ratio, which is 0.9. Okay, and if we work this out, we would get 0.659. Okay, so we know E1 now, which is at this point here, right? The next thing we need to do now is find E2. So E2 would equal, we're now on the over-consolidated line, so this line here. So this line here is the over-consolidated line, so we're using CR. So it would be minus CR. CR is 0.1, so minus 0.1 log. So now we've never done this before, but the final effective stress is actually smaller than the initial, right? The final effective stress we get to is 50. So it's 50 on the initial for this line was 200. Okay? So 50 on 200 plus the voids ratio. So the voids ratio initially is E1, which is 0.659. Okay? And if we were to work this out, we get 0.719. Okay, so this voids ratio, E2, is 0.719. So, once again, just to clarify what we've done, in this example, we've come down the normally consolidated line, and then we've reached a point where we now decrease the stress, which means that we have to go along the overly consolidated line. So this section, so ignoring that, so just down and up, is what we've got here. We're going down and up, where this line is normally consolidated, in red. Okay, so this line is normally consolidated. I'm going to put it in red, is the red line, and the blue line is over consolidated. Okay, so we've come down normally consolidated and gone back up over consolidated. Okay, so these 4 examples we've done should pretty much cover you for most examples you guys will get. If you don't understand any of them, I'd recommend going back and watching some because they're very important. Anyway guys, hope that helps.